Hi, in this video I'm going to introduce our textbook, Algebraic Structures with Applications, Abstract Algebra courseware for non-abstract thinkers. Now, when mathematicians think of algebraic structures, they think of groups, rings, fields. Now, we're taking a much more pedestrian approach. For us, algebraic structures are complex numbers, modular arithmetic, permutations, concrete structures that students can work with and understand, especially students who have difficulty dealing in the abstract realm. Okay, so abstract algebra, a course in crisis. In our school, our students just don't get it. Most of our students are pre-secondary teacher, and it's just like a foreign language. They can't read the textbook. The proofs seem to them as like magical incantations. It's like Hogwarts. They're just learning spells. They're only manipulating symbols. Okay. In fact, our students don't need to get it. The material in the conventional abstract algebra course is not particularly relevant to the material that's taught in high school. So most of our students will become secondary teachers or junior college teachers. It's very hard for them to relate what they learn in the class to what they might need in the classroom that they will be running. Can we teach something that will be more interesting and relevant for them? I believe that we can. All right, so let's think of the question, why don't they get it? Why do they have so much trouble with abstract algebra? I claim it's because they're insufficiently grounded in basic examples, like complex numbers, modular. Historically, these were the examples that motivated the abstract algebraic structures that we use now. Equivalence relations, this leads into cosets, symmetries, permutations. These things are basic things, much more concrete. They don't even have a grasp of these things. How can we expect them to grasp the abstractification of these concrete concepts? They've visited the zoo without touching the animals. They've had classes where they say, this is a complex number, this is modular arithmetic, this is a permutation. They don't really know how to work with these things. They've only seen them from a distance. They have no really intimate familiarity. So our strategy is to have them play with the animals and begin to see what they have in common. Right? So then if you play with a tiger and then you see a jaguar, you see there's some similarity there. Okay. All right, so some special features of our material. The textbook is meant to be read. There are reading comprehension questions in the text. Okay. I have started flipping my classes, so I do lectures on YouTube. I present the material using lecture, and then during class we work on problems together. The video series for this text is just beginning and will be completed by the end of this semester. I already did a similar video series for Jim Heffern's linear algebra book, so you can look on YouTube for that. And I'm going to do a video series for Rob Beezer's linear algebra book as well. So my students seem to find this very useful to have an audio presentation of the material. I would like them to be able to read the textbook, but it seems that this kind of helping hand is useful for them. Okay, so thanks very much.